Okay, we're going to look at section 2.5. We're in that descriptive statistics chapter, and this time we're going to look at the descriptive statistics that measure the center of a list of data. We are looking at, again, numerical descriptive statistics, and they're going to measure the tendency of the data values to cluster around certain numerical values. The three that we are going to look at are mean, median, which we already talked about in a previous section, and then we'll also look at mode. The mean is the most common. We also call that average. We want to distinguish between the population mean and the sample mean. So the population mean, remember, that's something usually that we don't know. It's that population parameter that we're trying to estimate. We denote it with a Greek letter, and this is the Greek letter mu. All right, so there's the pronunciation is given to you there. And we can, really, we know how to calculate an average. So we're going to take the sum of all of the data values, x, and we're going to divide it by uppercase N. We use uppercase N to stand for the size of a population. Okay, so if we have access to all the population members, then that's how we would think of calculating population mean. Now, typically, we do not have access to all the population members, so we're calculating a sample mean, right? It is denoted with x with a bar over the top of it. And again, we are going to add up all the sample values, sum all the x's, and then divide by, this time we use lowercase n, as lowercase n stands for the sample size, and again, it's denoted with that x with a bar over the top, and we pronounce it, when we see it, we say x bar. Okay, this is really key, this next line, that we round to one more decimal place than the sample values, and we're going to use the same label as the sample values. Okay, I'm going to refer to this often, all right, but keep that in mind. If you have a question about how many decimal places to round to, you're going to look at your sample values and round to one more. Sometimes you will be told specifically, either by the text or by me in an assignment, and if that's the case, then go ahead with whatever you're told in that specific situation. So we've said that x bar is used to estimate mu. So we're going to want x bar to be the best possible estimate. So just a couple things to tie this back to what we talked about in chapter 1. If we're knowing we're going to use a sample mean to estimate a population mean, we're going to use x bar to estimate mu. We want to have a random sample that gives us the best representation of the population. And then the other piece is we want the sample to be as large as possible. So the larger sample size. So both of those things impact the reliability of x bar estimating mu. Okay, so good to keep in mind. All right, let's look at an example. Let's look at this sample of home prices in a neighborhood listed in dollars. So it's a sample, so we're going to be calculating x bar. So x bar, we're going to sum up the x values and divide by the number that are there, which is 5. So if we sum up those x values, and I'm going to kind of truncate off those 3 zeros at the end for the thousands. If we sum those up, and you can, pause and do this on your own, but you sum those up, we get 2,213,000. Divide that by the 5. We get mean home price of 442,600. Okay, so notice I'm labeling that. Okay, we want to always label means or other statistics if we can, so we know it ties us back to the example, what the context is of the problem. Okay, so this is a measure of central tendency in this list of data, and it kind of makes sense because it is greater than two of the values. It's greater than 405K, and it's greater than the 393. All right, and it's less than three of them. All right, 450, 465, and the 500. All right, so it's that mean value. It's not an actual value from the data list, but it is right in the center if we kind of plugged it in there. Now, suppose that 500,000 was actually 850,000. All right, let's recalculate the mean if that's the case. So again, we have x bar. We're going to sum up the x values, and this time it's going to give us the sum of 2,563,000, and if we divide that by 5, our mean home price is 512,600. Okay, now if we think about, again, this is supposed to be measuring the central tendency of the data values, but this is, in this case, x bar is greater than 4 out of 5 home prices. So it doesn't really serve its purpose. It's not really giving us an idea of where the center is. And it's obvious why, because we've got this large value is really influencing the mean value. Okay, so that's something to keep in mind about this measure, this descriptive statistic of a mean. The mean is influenced by all of the sample values, so really large or really small values can just sort of unduly influence it. Okay, so we have another measure, median. We talked about this before. It is the middle number. All right, we're using the same definition. When measurements are arranged in ascending order, and it's not influenced by extreme values like the mean is. Okay, so a little bit of review here. The median we denote with an uppercase M, and to find it, we're going to arrange the sample values from smallest to largest. And then if we've got if we've got odd sample size, we just take the middle value, and if it's even, we take the mean of the two middle values. So let's list the data values. We start with 393 from, I guess I should finish that off. List from smallest to largest. 405, 450, 465, and then for the first list, it's 500. For the second list, it's 850. Okay, so for the first sample, we can pick out the median. It's the middle value. There's an odd number, so that middle value is 450,000. And then what about the second sample? Well, it is still the middle value. It's not influenced by the fact that that largest value is something different. So we get the same median price. Okay, so in cases like when we have extreme values and we really want to get an idea of the center of data, median is a better choice. Or a lot of times we consider the mean and the median. All right, so summary, median gives better representation of a typical value when there are extreme values because the mean is influenced by those extreme values. The third measure of central tendency is mode. Mode has the distinction that it can be used not just for quantitative data, but also qualitative data. So I'm seeing a little bit of a typo that I want to get fixed here. That should say instead continuous. I apologize for that. All right. Okay. So if we've got quantitative discrete data, then the data value that occurs most frequently in the data set is the mode, so it's actually a data value. If our quantitative data is continuous, so we don't necessarily have distinct values, but we come up with classes. You think about when we created frequency tables and did histogram for continuous data, we created classes. So we think of mode in terms of the class that occurs most frequently when we have continuous data. And then for qualitative data, it's the category that occurs most frequently. And we can have more than one mode. Okay, so let's look at these examples. So here we've got some qualitative data. We're just given a bar chart. Easy to pick out the mode. Of course, the brand that is most frequently owned and used by, and I'm not sure what the population here is, or the sample is Apple. We probably didn't even need a bar chart to see that. Apple is the mode, and it has frequency of 24. All right, and then the next frequency down looks like it's about 7. All right, so a big drop. All right, let's look at this little data set and use that to find these measures of central tendency. I'm going to start by looking at calculating the mean. All right, x bar equals, we're going to sum up the x's and divide by the n. All right, in this case, our sample size is 12. So we have repeating values here, so I'm thinking of this as 2 times 11, because that shows up twice, plus 4 times 12, there's 4 12s, plus 13, plus 15, plus 17, plus 3 times 22. And then that whole thing is going to be divided by 12. Okay, so you can pause, plug that into your calculator. Then we get 181 for the sum over 12. That results in 15.08 repeating 3. Now remember, we want to round to one more decimal place in the data, so we're going to go out to tenths. So we get 15 point, that 0 will round up to a 1 since the 8 is 5 or greater. All right, so there's our sample mean, 15.1. All right, let's look at median. It is nicely arranged for us from smallest to largest. Our sample size is 12, it's even, so we're going to look at the middle two numbers. So 1, 2, 3, 4, 5, 6. So here are our middle two numbers. So taking the average of those, we get 12.5 for the median. Okay, now let's look at mode. All right, mode, we've got 4 12s, and we have 3 22s, 2 11s, but 12 is the one that occurs most frequency, or with greatest frequency. So the mode is that data value of 12, and it has frequency of 4. Okay, sometimes it's easy to kind of confuse the frequency with what the mode is. We just want to keep in mind that the mode is always the data value. Okay, that wraps up 2.5.